now, how we are programming is the approach is called imperative programming. Now, what happens with imperative programming is as soon as you hit like you hit a data request, what happens is the user thread. So basically, the thread model which we are working with imperative is a user thread model, right? I mean, every user that comes to the system that makes a request is assigned a single thread. So it's a thread model, user thread model programming approach, right? And what happens is as soon as user makes an call to database or let's say another API, what happens is the thread goes into blocked or waiting state, right? So there are two things. So there are more waiting time for the thread than the actual functional programming or the execution time, and two, it makes the thread lifecycle a little longer, right? Which is not efficient way of programming. What happens is if you have multiple users coming into your system, your processor will have to do multiple thread switches, right? I mean, if you know thread switching model, time slicing, and preemptive scheduling, your thread your computer has to spend more time on rescheduling the threads, right? Thread switching. So what reactive programming does is it spawns shorter thread time. So what happens is as soon as you make a DB request or a data request to DB or to another API, what happens is the call returns immediately, and the data gets pushed as soon as it is ready from the database. And yeah, and that data gets pushed as an individual event as soon as it is ready, and as in every single item in the result set gets pushed. What happens is the app receives on next call from the DB layer as soon as for every request. For every data layer you receive one on next call, and as soon as your data transformation finishes, you receive an on complete. That marks the completion of your data streaming. And uh, yeah, and that this is why it is called event driven stream. It drives through the events. Like it could be on next event, it could be on complete in case of will reach. Okay, so there is a simple use case, like if there is no data to be received, like in case of save or update, or if you are making a select call, there are no data to be received, all you receive is an on complete event, which tells you that there is no data to be received, but it finished successfully. Like if it's save or if it is update, or if it is even if it is a select call, you have no data to be received. And in case of error, you receive an on error callback, like if you see in the diagram. That is why it is called event driven stream. Second thing, it supports back pressure. So what happens is what happens with reactive programming is it if the data source is producing kind of more data than your application can process, your application can tell your database to hold off. I mean, it needs some time to processing the data that has been received. So it can tell the database layer to hold off till the data is received to the application. So this is what is called back pressure. One thing I actually one thing I actually wanted to highlight here on error callback is, unlike imperative style of programming where we handle data using try and catch block, what happens here is you don't, I mean, even if there is no block in calls as such. So all the data transformations does happen in parallel. So that try catch error handling doesn't help you, because your request may have passed through by the time. So it in the similar way, it gives you another way of error handling that is smart, and that is programmed within your data transformation as well. We'll see it in the demo. And streaming of data. So there is an additional feature coming up with this as well, with Spring Web or Webflux as it is called. So if your client, if you are registered or if you are connected to an API, what happens is as soon as, or if there are any additions in the database can push the data back to your application, and that is called streaming of data. So functional style of programming. It's as I told you, reactive programming style by nature embraces functional style of programming. It follows similar programming style as of streaming API. So if you know how to program with streams API, your life becomes easier when you go on with reactive programming. It's easier to work with lambdas, the programming approach, and it follows reactive stream specification. So what is reactive stream specification? So it's a generic specification made by Java world, or actually it's a generic specification. It tells you what all are the endpoints or the uh, uh, necessary interfaces required to make a application React enabled. So there are four general interfaces: publisher, subscriber, subscription, and processor. So publisher is nothing but your data layer. Your data layer. Subscriber is in general your API. So publisher actually has a subscribe method. So what all the sources or APIs can do is call that subscribe method, and what they receive is an on subscription callback. So in fact, the subscriber should have an on subscribe callback. So in return to the subscribe callback, all you receive is on subscribe callback with a subscription with a subscription instance. And with the subscription instance, API or the data or your API can request the data or cancel the subscription, of course. But one thing to note here is, if you see point 3, the requesting of the data, you can pass an parameter. That's if you are seeing n. What happens here is you can tell the application, tell your database layer that pass me like 100 data at a time. This is the fundamental of back pressure I was referring to earlier. And in response, what happens is your database layer, as soon as your data is ready, it gives you on next callback. And it could be per data. I mean, if you have like 100 rows to be returned, you could have 100 on next calls, and on finishing on completion of your data, all you receive is on complete call. Of course, if at any point in time the subscriber wishes to cancel the subscription, it can go ahead and call the cancel method on the subscription. It marks the completion or cancellation of the subscription you are having at the point in time. And the last interface I was referring to is an processor interface. Yeah, processor interface is nothing but an interface that implements publisher and subscriber, both of the interfaces, by extending actually both the interfaces, so that you have both the advantages right in front of you with the same interface. Popular React libraries. Okay, so React libraries is nothing but all the libraries that support reactive stream specifications, right? So in Java world, there are few reactive reactive libraries available. RxJava is popular and quite old library available in Java. Reactor Java. Reactor is kind of pretty much popular in the Spring world at the moment. And actually, with Java 9, even Java world introduced a flow class, which is kind of a move towards the same approach, same reactive approach. So okay, so we'll now dig a bit more on Reactor, and the demo we are going to see is also on Reactor. So Reactor core is one of the most popular libraries, as I've told you, in Spring world. It has two main classes, Mono and Flux. I'll elaborate it while we go on demo, but just to give you a brief, Mono is something single element representation. So it could be 0 elements, it could be 1 element, nothing else than that. And Flux is a series of elements. It could be from 0 to n. So one thing to note down here is non-blocking calls needs a support from database driver and everything, right? So if your database driver doesn't support non-blocking calls, you're screwed. I mean, you don't achieve the entire advantage. And at the same time, your application layer or your application server or web server also needs to support the same thing, right? So as of now, Spring supports Netty. Actually, is the new default with Spring WebFlex. Yeah, so that is one thing to note down here is Reactor core library supports this database I mentioned. In NoSQL world, it supports quite more MongoDB, Cassandra, Redis, Couchbase, and in SQL world, it kind of made an tie-up with R2DBC, which is again a third-party library which supports a couple of databases like Postgres, MS SQL, H2, and there is a third-party library for MySQL as well. So MySQL is directly not integrated as part of R2DBC, but there is an additional library through which you can have a couple of features of MySQL under the Reactive world. It's not totally supported. Yeah, and as I've told you, yeah, Netty is the new default server embedded with Spring Boot's WebFlex dependency. So in conclusion, I'll say reactive programming approach, if used correctly, offers a great advantage. So the main advantage of it is the higher throughput it offers. I mean, with the same bandwidth available, you can have the more processing power. The only thing is you need the support of reactive libraries throughout. I mean, your database driver must support reactive style of programming. If there is a chain of APIs, of course, all of those APIs from end to end needs to be supported by or actually covered, should be covered under reactive programming style. If at any point in time you have a block in call, the entire advantage that is being offered by reactive programming is gone. So yeah, so there are limitations as I was referring. There are, as of now, there are limited database drivers. It needs coding practice, of course. So it's not like regular blocking calls. If you remember our try catch error handling or resiliency, how we handle the resiliency, because at no point in time there is a blocking call. So if you consider the try catch block, the actual data processing which you are doing, that must have passed by. So there is no way you can handle the regular programming approaches. You let it be try catch or let it be the resiliency for resiliency or resilience 4G sort of APIs. Yeah. So a couple of useful links. I'll pass on this presentation again, of course, so that you have this links. We'll move on to our demo. Any questions actually? I'll take it as no for now. And of course, I'll give you time towards the end of our session as well. So it's a simple application. If you're still seeing my screen, it's a simple application wherein I'm doing nothing but saving a couple of users to the database and retrieving those users from database. But the only thing is, the entire lifecycle of this API is non-blocking. All I'm returning is flux and mono objects, as I was referring to earlier. So as I've told you earlier, flux is something that represents multiple elements. So I'll take a simple use case. Yeah, here. Yeah. So in case of save employees, what we return, right? The saved employee, right? So if I'm saving one employee, what I return is usually the same employee or the ID of the employee. So it's a single instance. Or if there is an error, it's nothing. So it's 0 or 1. So error or 1 employee. So that is why I'm returning mono of employees here. And in case of list of employees, like I'm trying to get users, what I should be returning is, could be multiple users, right? Of course, it could be 0 if there is an error, if there is no data. It could be up to n. So it could be 0 to n, or in case of save, it could be mono. So it should be 0 or 1. Yeah, it's a simple use case. I'm saving this data. I think that will be returned with the ID. So we'll see the implementation. Even on database layer. So here I've done nothing. I'm just using the reactive repository. Yeah, I'll go to reactive repository, and there are default methods of save and update, right? Or in fact, for a lot of things. Okay, so here is a reactive repository. So if you observe here, it's a reactive CRUD repository. Usually what we use is CRUD repository. Here it is a reactive CRUD repository, right? So that's the only difference. And the rest of the advantages that are being offered are the same. One thing I told you to look down here is, give me 1 second. Yeah, Netty. Netty is the new default web server with Spring Boot, Webflex mainly. Now there are a couple of transformations. So the important aspect. So with usual programming like saving the data or retrieving the data, it's fairly simple, as you are doing with your current programming approach. The only thing or the only hurdle that usually people faces are the transformation of data. So I'll give you a few examples how to transform the data, and we'll get it from there. So here I'm just requesting all the data. That's just a request of data. What I can do is, yeah. So this is the simple transformation example. Names. So what I'm doing is I'm getting the names of the employee. Yeah. And if you see here, it's fairly simple. What I'm doing is find all. It's the method. It's the database method to find all the employees from repository. What I'm applying a map function. What I'm doing, I'm transforming is employee to employee.get names, and I'm returning the same instance. one thing I wanted to show here is, I mean, that's again part of Streams API, but still I would like to cover here is map and flat map. So flat and flat map are actually, it's actually nothing but transformations, way to transform your data. So what happens with map is a one-to-one transformation. Like if you have if you have n inputs, you will have n outputs, but it could be of different type. Like here, it's from employee object to string object, right? So it's a linear transformation, one-to-one transformation, and flat map is kind of a bit trickier. What happens with flat map is it flattens all of your data and produces different number of items. So if you see, it goes. So this is very popular diagram, and this link is already shared in the presentation. But if you see here, you go on with a circle and you receive a rectangle, right? So you have totally different way of representing the data, or you have totally different data being received after this transformation. Yeah, so this is also one more filter transformation, and what I do is I filter the employees by their department. So return all the employees who are part of IT department. Yeah, filtered employees, and if you see here, all the employees returned are pertaining to department IT, right? And this is what I wanted to demo. This is the example of flat map. What I'm doing here is I'm taking out all the employee names. I'm splitting them by space. I'm transforming them to uppercase and returning a stream of data again, flux of data. But if you, so this could be better explained when you have dependencies like employee, and that they have a different, like employee and event, or event and employee. So they have dependent objects, but I was not having a dependent object at the moment. So I transformed the same object I mean, I splitted the names by space, and this is what I'm returning. So that could be, so one name could have 2, 3 outputs, one name could have just one output. So it's basically and X inputs could have Y output. Now this Y could be anything. It could be more than X, less than X. Now here, of course, it would be more than or equal to X. So and again, so what I'm doing is flat map on employees. I'm converting the object to flex. Flex.just is a handy method which you can use to convert your object or an array of objects to the flex object. I'm again applying it. I'm applying map because I still want to transform it to uppercase. So I'm transforming it to uppercase, and that's pretty much it. Yeah. So this is what I added. Of course, it doesn't beautify this, but yeah, this is the data which is getting returned. Spring Reactive, this is actually a good documentation offered here, and as I was referring to earlier, yeah, this all are the databases that are being supported: MongoDB, Cassandra, Redis, Couchbase, and R2DBC is an external library, which here just here. Yeah, this is the repository of R2DBC, and if you see here, it supports MS SQL, H2. Yeah, in the moment. There was one more thing I wanted to show you. Yeah, there are dependencies. It's nothing. Okay, I'll show you one more thing. Yeah. So this is just my my database connectivity. That's all configuration that is needed. There is nothing else I've done apart from this. And the dependency is R2DBC, of course, R2DBC MySQL, Spring Boot Starter, R2DBC, and Webflux. That's all additional libraries I need. Lombok is again just for data. I mean, not to write all those getter setters. That's it. That's all you need. So there are, so again, yeah, even with test cases, so it's the same thing, right? I mean, if your calls are non-blocking, you have to write your test cases as well to be non-blocking. So here are a couple of examples. I mean, if I'm calling, okay, I can run this and Yeah, I changed something. Sorry. But again, if you see this, it is calling an endpoint. It is getting the data. So exchange is the function which actually invokes the stream, invokes the API. Then what you do is what you write here is expect status. So what status you are expecting, and is okay is what you are expecting, right? And result, return result. What is your expected result? I mean, my expected result was long, and get response body. And based on that response body, I'm writing expect next, right? So if I go back to this endpoint, oh, yeah. So here what I'm returning, I actually changed this use case, but usually what I was returning is 1, 2, 3, 4. So stream of data, nothing else. And actually that is why that stage case was failing. Sorry, but ideally yes. So that is what you expect next. But till what point you want to do? I mean, this could uh, stream like, I mean, infinite number of data, but you want to test a few of them. So I tested 3 of them, then I canceled my subscription and verify is the actual verifier. That's how it is, at how it is done. One thing I wanted to show here on streaming API. So actually there are 2, 3 things I couldn't demo today, but one last thing I wanted to was, yeah, give me one moment. Yeah. So this is an infinite stream of data. I'll parallelly open the log as well, just in case you want to see.
Nice.
Yeah, if you're seeing there are on next calls, like continuous on next calls happening. So it's an infinite. So till you cancel the subscription, this data will continuously start or continue flowing. This is what I was referring to when I told you stream of data, right? I mean, this could be come in from database. This could be just a static data as it is doing now. And as soon as I close this browser, it will trigger an on cancel event. Yeah, on cancel event, and that's done. Yeah, because sorry, this is also going on. So this doesn't behave well. Postman doesn't behave well actually. Yeah, that's about it.